Okay, so our first step is to find the area of the base. The base is actually this shape here. Kind of like a rectangular ring almost. Easiest way I can find to find that area is just this. I have the big rectangle, 32 by 48, which is going to be, yes, 1536. And then I have a small rectangle. 2 feet on each side would make this 28. Makes this 44. So that's 28 by 44. $12.32. So 304 square feet is that area of that base, right? So in the volume, $304 square feet times what? 8 feet, which is 2,432 cubic feet. How many of you got that? Both of you? Jake? No? You still got the right answer?
No, I didn't get that answer.
Okay. That's what it should come out to. This is most of what we're going to be doing today. The problem is what we're going to be doing today isn't going to be nice even numbers like that. I got a little sloppy here, but that's okay. And there's going to be a lot of nice even numbers. You might be told that this is 30 feet here, and this is 48 feet here. But that's 10 inches thick. What we've got to do is we've got to convert that 10 inches into 10 twelfths of a foot and work with it from there. So I want you to try to do, this is 8 feet high here. What I want you to try to do right now, in your notes, see if you can find the area of that ring there. So we'll get a little look at this. The outside, of course, is 30 by 48. Which is just, come on, 1440. That's square feet. The inside is the tough part. 10 twelfths here and here ends up being a total of 20 twelfths. The 20 over twelfths is 1 8 twelfths, or 1 2/3 feet is being subtracted there. Okay? So that means that this dimension is 28 1/3. That's 30 minus 1 2/3. This dimension here is 46 1/3, which is 48 minus 1 2/3. So you've got 28 1/3 times 46 1/3. For my calculator, I'm going to have to finagle this a bit. $113.12.78. So I subtract there, I get 127.22. Is that what you got, Jake?
No, I did it wrong. I only did 2 inches. I didn't.
Oh, you didn't do it off both sides?
Yeah,
Okay.
I got 127.174.
What'd you get?
I got 127.17.
That would be more than acceptable. Yes, 1.7.
Awesome. Yeah, because I just took 10 and divided it by 12 to find that, and I multiplied that by 2 and subtracted it from 30 and 48.
Okay. Yeah, that can work. Okay, now that you have that area, volume will be quick to follow. 127.22 square feet times 8 feet of height. $1,017.76 cubic feet. Now, obviously, what we're doing here is we're looking at concrete basements. We don't order concrete in cubic feet. We order concrete in cubic yards. How many cubic feet are in a cubic yard? 27. Very good. That is my cubic feet per cubic yard conversion. So divide by 27. 37.69 cubic yards. Which I'd round, usually I'd round to the nearest quarter yard, so 37.75. Of course, I haven't added the waste factor yet. We haven't talked about that at all. Any questions? Okay, so the next step is what happens here's the outline of the wall. Let's say that this is supposed to be 28 by 42 building. We all know that when you go to pour footings, you don't pour them 28 by 42. They extend outside of the wall, and they extend inside of the wall, right? The size of the footing is always at least double the width of the wall. Standard. That's minimum code. 8-inch wall, you must have a 16-inch footing. 10-inch wall, you must have a 20-inch footing. For us, we are going to do, I guess it doesn't say what thickness of the walls there are on these here, does it? We're going to make it easy on ourselves and do a 24-inch footing. Okay? So what that means, we're also going to assume 10-inch walls. You can pour an 8-inch wall, but if you have good sandy soil, for block you need at least a 10-inch block for a basement. I mean, I've seen it if you do like a short basement, do an 8-inch block, but 8-inch block if it's a more than about 4 feet high, and if it's heavy soil at all, it'll start to cave after a while. It starts to crack and push in. So here's what we're going to do to make this relatively easy on ourselves. We're going to do 6 inches outside the wall. So this is a 28 foot by 42 foot building. We're 6 inches outside what the wall would be, 24 inches total width. And we are going, code requires at least 1 inch of thickness per foot of wall height. So we're going to assume this is an 8-foot wall. So this is an 8-inch thick footing. Find, number 1 for me, I want you to find the area of the top of this quick. I'll give you a few minutes to find that, then we'll go from there. So what is our outside dimension here? Our outside dimension. We got 28 feet here, right? We're adding 6 inches to each end, so that's 29 feet. I made it easy on you. This is 42 feet here to here. We added 6 inches on each end, so that is 43 feet. So that's 29 feet by 43 feet, which gives us an outside area of 1247. square feet. Is that what you had?
No.
No?
I keep forgetting to double it. I just do 6 inches, not.
Oh, sure.
I just remembered to multiply by 2 and then subtract that answer. I mean, I think it would be all.
On the inside here, we're taking 24 inches or 2 feet here and 2 feet here. So 29 is what we got to come off of, right? Minus 4 would be 25 here. 43 minus 4 makes it 39 here. $975 square feet. Subtracting, we get 272 square feet. How do I change that into a volume? Not 8. I'll show you a trick. 8 twelfths. 0.666. You can just do 8 twelfths. So I can take that 272 just times 8 divided by 12. 181.333. And that is cubic feet. And of course, what do we got to do with that?
Divided by 27.
Divide by 27 to make it cubic yards. .71. So I'd probably round it to 6. I'd probably round that up to 7 yards just because it's so close to 6 3/4. So on that packet I gave you yesterday, it said foundations, footings, and slabs. If you flip to the back, there are 3 outlines. For these 3 outlines, problem number 1, it says 8-inch wall. So that means you're going to do a 16-inch footing. The wall is centered on the footing, so that means there's 4 inches sticking out outside the wall, 4 inches sticking out inside the wall. That's actually, I should label that A, not 1. For B, it says 10-inch wall. I'm going to have you bump that up to a 24-inch footing just to make it easier on you. 6 inches outside the wall. So that one's going to be just like the one we just did. For C, it says 10-inch wall. So same thing I just said for B. 24-inch footing, 6 inches outside, the rest in. For each of these, I want you to find cubic yards of concrete for footing. Now these walls are like 7'6", 7 foot, whatever. We're going to go minimum 8-inch footing. So we're going to do an 8-inch footing for all of them. 2 cubic yards of concrete for the walls. And 3 cubic yards of concrete, assuming a 3-inch thick floor. The floor, I'm going to give you a little hint. Up here, when we did our walls, this area right here, this is what we subtracted off on the inside. That's the area covered by our floor. So if I wanted the volume of the floor, I would just take that area times 3/12 because it's 3 inches thick. That would give me the cubic feet for the floor, and I just convert it to yards. So I'm going to let you guys give these a shot. This is your, you don't have to be exact. I mean, this is estimating basically here. From your guys' point of view, you're in the woods, not the concrete. But you need to be able to do a rough estimate to put it on an estimate to bid it out, or you are subbing out the concrete to someone to do the bidding for you to make sure they're not like drastically overcharging you.